Okay, so now let's do the next question. Obtain the Norton's equivalent network for the circuit over here. And here you can see this is a Wheatstone bridge, right? So here, as usual, this is the two terminals. So which means the first thing we need to do is to short these two terminals, right? Join these two terminals, and the current that is flowing from A to B is what you need to find. That is the Norton's current. Okay, so shorting A, B, we get the circuit. So you just need to join this. Okay, so which means the circuit will now become like this, right? A voltage source over here. This is 10 angle 45 degree volt. Okay, and this is a capacitor with a resistor. This is a resistor over here. We have another resistor over here. We have an inductor. Then we have a resistor over here. Okay, and then now we are going to join these 2 points, so this will become a single branch. Okay, and the current that is flowing in this direction is what you call as IN, which is the value of the current you need to find. This is 5 ohm, this is 10 ohm, this is 2j ohm, this is 5 ohm, this is minus 2j, and this is 10 ohm. Okay, so which means now you need to find the value of Norton's current IN. Okay, so basically what we do is we are going to apply mesh analysis. Okay, so here there are totally 3 meshes. This is mesh 1, so this is current I1. Let the top mesh be I2 and the bottom mesh be I3. Okay, so in that case, what is IN? What is the equation for IN? IN is the current through this branch, right? And in the same branch, 2 currents are flowing. One is I2 and the other is I3. Okay, so if you look at, so what is the equation for IN? So to find the equation for IN, simply look at the I2 and I3, right? Because both the currents are flowing in this same branch. So if you look at I2 is flowing the opposite direction of IN, right? I2 is flowing the opposite direction of IN, therefore I2 is negative. And what about I3? I3 is flowing in the same direction of IN, which means I3 is positive. Therefore, IN is equal to I3 minus I2. Which means if you want to find the Norton's current IN, you need to find the value I3 and you need to find the value I2. Okay, you cannot apply the same shortcut method that you have applied when you are trying to do the Thevenin's equivalent of the same circuit. See, because there the branch is open. What is VTH? VTH is the open voltage across A and B. Okay, so since this is open, then it is very easy to say that the current that flows in this branch is the same current that flows through this branch. Likewise, the current that flows in this branch is the same current that flows through this branch, because no current will flow through this if this branch is open. You cannot apply the same technique over here, because in this time there is a branch, there is a short. Here what is the Norton's current is that the Norton's current is the current through the terminals when the 2 terminals are shorted together. So which means if the current is flowing through this branch, if there is a current flowing through this branch, some of the current will flow through this branch and some of them will flow through this branch. In same way, if there is a current that's flowing in through this branch, then some of the current will flow through this branch and some of the current will flow through this branch. So therefore we can never say, just like this, we can never say that these 2 branches are in series. You can never say that. Okay, so which means the only way to do this is by applying the old-fashioned mesh analysis. So let's do this question. So here we apply equation for mesh 1. Okay, equation for mesh 1. And here, if it is equation for mesh 1, I1 is positive and I2 and I3 are considered as negative, right? So here I1 is positive, so I1 into, and I1 is touching this 10 ohm, this minus 2j and this 5 ohm. So 10 plus 5 is 15. So we have 15 minus 2j. Okay, 15 minus 2j minus I2 into, and what about I2 in mesh 1? I2 is touching only these two elements, right? 10 minus 2j. So this is 10 minus 2j. Okay, I2 into 10 minus 2j. And what about I3? In mesh 1, I3 is touching only this 5 ohm resistor, so it is nothing but I3 into 5. Okay, and this is equal to the voltage source, and this I1 is flowing out of the positive terminal, which means this positive terminal is generating I1, so it is plus 10 angle 45 degree. Okay, this is the equation for mesh 1. Let me see what is 10 angle 45 degree. 10 shift angle 45 degree is equal to 5 root 2 plus 5 root 2j. So I am going to rewrite this equation. So I can say that this is I1 into 15 minus 2j minus I2 into 10 minus 2j minus I3 into 5 is equal to 5 root 2 plus 5 root 2j. 5 root 2 plus 5 root 2j. Okay, so this is the first equation. Now I'm going to write the equation for mesh 2. So equation for mesh 2. Okay, so in equation mesh 2, I2 is considered positive and I1 and I3 is considered as negative, right? So minus I1 into, and in mesh 2 I1 is touching these two elements, right? 10 minus 2j. So it is 10 minus 2j over here. Okay, and what about I2 plus I2 into, and I2 is touching these three elements, that is 10 5 ohm, this 10 ohm 5 ohm is minus 2, so it is 10 plus 5 15, so it is 15 minus 2j. Okay, plus I2 into 15 minus 2j, and I3 is not touching any element in mesh 2, so there is no I3 over here, so this is equal to, and there is no voltage source also over here, so it is equal to 0. Okay, this is the equation. Okay, let me see if there's any trick I can apply over here. No. Okay, so this is the equation. Okay, so this is the equation for mesh 2. Now I'm going to write the equation for mesh 3. Let me write the equation. So equation for mesh 3. Here in mesh 3, I3 is positive and I2 and I1 are negative. So and in mesh 3, I1 is touching only this resistor, so it is minus I1 into 5. Okay, and I2 is not touching any element in mesh 3, right? So therefore there is no I2, it is I2 into 0. So you have left with only I3. So I plus I3 into, and I3 is touching this 10, this 2 and this 5. So it is again it is 10 plus 5 15, so 15 plus 2j. Here also it is 15 plus 2j. Okay, is equal to, and there is no voltage source over here, so this is equal to 0. Okay, so this is equal to 0. You know, if you want, I can from here I can find the value of I1, and here also I can find the value of I1, and I can substitute that value over here, right? Those values are not, I can substitute over here. That's one way you can do is apply this problem. Let me try that method. Okay, that means here what I'm going to do is that I'm going to write that the equation for I1 is, or I'm going to say the equation for I2. I'm going to say the equation for I2 is equal to I1 into 10 minus 2j by 15 minus 2j, right? Am I correct? Yes. Okay, 15 minus 2. This is the equation for I2. So which means I can substitute this equation over here. Let's see what will happen. Okay, let's see what will happen over here. So that is one thing. Or do we have to apply Cramer's rule? Should I apply Cramer's rule? I think I'll apply Cramer's rule, right? No need to do this method. I want you all to try this method. Okay, what I'm going to do is that here I'm going to substitute here. You can see this equation is consisting only of I1 and I2, and this equation is also consisting of I1 and I3. So I want all of you to try by finding the value of I3 in terms of I1 and I2 in terms of I1, and substitute those two equations in I2 and I3, and then from here you can find the value of I1. But then also it doesn't make sense because you need the value of I3 and I2, right? So I think we apply Cramer's rule. Don't need to apply this method. We can directly go straight for the Cramer's rule. Okay, so let's apply the Cramer's rule. So representing these three equations in matrix form, we have the coefficient of I1 is 15 minus 2j, The coefficient of I2 is over here, it is minus of 10 minus 2j. Minus of 10 minus 2j. So let me write that, minus of 10 minus 2j. Then here it is minus 5. Minus 5. This is the first equation. The second equation, the coefficient of I1 is minus of 10 minus 2j. Minus of 10 minus 2j. And the second equation is 15 minus 2j. It is 15 minus 2j. And the second equation, there is no I3, which means the coefficient of I3 is 0. The last equation, the coefficient of I1 is minus 5. The coefficient of I2 is 0. And the coefficient of I3 is 15 plus 2j. 15 plus 2j. Okay. 15 plus 2j. Okay, so this is the equation, and then you have over here as I1, I2, I3, and the constants are basically, you have 5 root 2 plus 5 root 2j. Then you have over here 0 and 0. This is the constants. So now I'm going to find the value of I2 and I3. First I'll try and find the value of I2. So I2 is equal to the determinant of 15 minus 2j over here, minus of 10 minus 2j is over here, and minus 5 over here. The second column is replaced with this, so you have 5 root 2 plus 5 root 2j, 0, 0, and over here you have minus 5, 0, 15 plus 2j. This is the numerator, divided by, and the denominator is the coefficient matrix, which determines the coefficient matrix, which is 15 minus 2j, minus of 10 minus 2j, minus 5, minus of 10 minus 2j, 15 minus 2j, 0. Here you have minus 5, 0, 15 plus 2j, and therefore I am going to find the value of I2. So I2 in the numerator, I2 is 15 minus 2j into 0 into 0. We don't have to calculate that. We have already left with this, right? This is minus 5 into, so we have minus of 5 root 2 plus 5 root 2j, okay, into, and if you multiply these two, this is nothing but, we have minus of 10 minus 2j into 15 minus 2j, 15 minus 2j, and then that's it, right? Minus of minus is 0, so this is it. Only this much is there in the numerator. Now let's see the denominator, and in the denominator we have 15 minus 2j, 15 minus 2j into, okay, and 15 minus 2j into 15 plus 2j, 15 minus 2j into 15 plus 2j, okay, that's it, right, over here. And then you have minus of minus is plus, so you have plus 10 minus 2j into 10 minus 2j into, and here you have minus of again 10 minus 2j into 15 plus 2j, 15 plus 2j, okay, minus 0. So that's it. This is the second term. And what about the third term? The third term you have minus 5 into, this is 0, and this is minus of minus is plus, so which means you have 5 into 15 minus 2j. This is the denominator, okay. So which means you have basically, let me find the value of both the denominator and numerator. Here minus of minus will get cancelled, right? So this will become plus, right? So you are left with, so the numerator is having the value 5 root 2 plus 5 root 2j into 10 minus 2j, 10 minus 2j into 15 minus 2j, 15 minus 2j. This is the value you got, okay. So this is So this is basically, let me see, we get 185, let me write it over here, 1385.929 1385.929 plus 678.823J. Okay, this is the numerator, and the denominator will take some time, I think, right? So here the denominator is, you have the first term, you have 15 minus 2j, let me write that, 15 minus 2j into 15 minus 2j into 15 plus 2j into 15 minus 2j into 15 plus 2j, and you get is 3435 minus 458j. Okay, that is the first term. Now what about the second term? Second term, you have minus, this minus comes over here, right? So this is minus, and you have over here 10 minus 2j into 10 minus 2j into 15 plus 2j. That is, you have 10 minus 2j, 10 minus 2j, and then you have 15 plus 2j, which is equal to 1520 minus 408j. This is the second term. Now the last term you have is minus, right? So it is minus over here. 5 into 5 is 25, right? So you have 25 into 15 minus 2j. 25 into 15 minus 2j, which is equal to 375 minus 50j. This is the equation, which means your denominator, so here you have 1385.929 plus 678.823j by, now your denominator is, let me see, it is 3435 minus 458j. Okay, then we have minus 1520 plus 408j, then you have minus 375 plus 50j. Let me see that if it's correct again. That is 3435 minus 458j minus 1520 plus 408j minus 375 plus 50j, and you get is a simple number, right? 1540. This is your denominator. Okay, this is your denominator. So which means the value of I1 is 1385.929 plus 678.823j divided by 1540, and you get the answer as 0.9 plus 0.441j. This is the value of I1. Sorry, this is the value of I2, right? It's the value of I2. Or in other words, let's see if I'm going to convert this into polar form. It is 1. Let me see, this is angle 1, angle 1.002, 1.002 angle 26.095 degree. Okay, this is the value of I2. This is the value of I2 that I got. Okay, I hope this is correct. Okay, this is the value of I2. Next I'm going to find the value of I3. Okay, so to find the value of I3, I3 is equal to the determinant of, and here the first two columns will be the same, right? That is 15 minus 2j. Then we have minus of 10 minus 2j. So 15 minus 2j minus of 10 minus 2j. You have minus 5. Here you have minus of 10 minus 2j. Then we have 15 minus 2j. And then you have 0. And the last column it is 5 root 2 plus 5 root 2j. 5 root 2 plus 5 root 2j. And you have 0 over here and 0 over here. Okay. By, and the denominator will be the same, that is 15 minus 2j minus of 10 minus 2j minus 5 minus of 10 minus 2j, 15 minus 2j, 0, and here you have minus 5, 0 and 15 plus 2j. Okay, this is the value of I3. So here I already found the value of denominator, so simply I need to find the value of the numerator, right? So the numerator is 15 minus 2j. I think I'll just choose this number, right? This is basically, we have nothing over here. Let me see if I multiply this will cancel, no use. So this is the only answer left behind. It is 5 root 2 plus 5 root 2j, okay, into, and this is 0, and here you have plus 5, so this is becomes minus 5, so it goes 5 into 15 minus 2j. This is it, okay. Divide by, and the denominator we have already found, it is 1540. So this is 1540, okay, and this is equal to, let me see, we get over here 5 root 2 plus 5 root 2j, close the bracket, into 5 into 15 minus 2j, okay, 5 root 2 plus 5 root 2j into 5 into 15 minus 2j, okay, so you get the answer as 601.041 plus 459.619j divided by 1540, which means you will get the answer as 601.041 plus 459.619j divided by 1540. So basically you get the answer as 601.041 plus 459.619j divided by 1540, and you will get is 0.39 plus 0.298j. Options converted to polar form, and you get the answer as 0.49 angle 37.405 degree amperes. This is the value of I3. Okay, so now I can say that IN is equal to I3 minus I2, which is equal to what is I3? This is I3, which is 0.39 plus 0.298j minus, and what is the value of I2? I2 is this one, 0.9 minus 0.441j minus 0.441j. So this is equal to, so you will get the answers 0.39 plus 0.298j minus 0.9 minus 0.441j, and this is equal to minus 0.51 minus 0.51 minus 1 point minus 0.143j minus 0.143j. okay, this is the value of in. Options, let me convert this to polar form, and I get the value of in as 0.53 angle minus 164.337 degrees amperes. This is the value of in. okay, now I'm going to find the value of the Norton's impedance, right? So to find Zn, okay, to find Zn, I'll write to the next page. To find Zn, we have over here, which means we just simply, this is the circuit, right? So we just simply short this voltage, right? Simply combine these two voltage. So this will simply short it. So by shorting it, the circuit will become like this, and one more line over here. Then the rest of the element will be the same. Okay. So it's a capacitor and a resistor in the first branch. Capacitor and a resistor. In the second branch we have is a resistor. In the third branch we have a resistor and an inductor. And in the last branch we have a resistor. Okay, and your Zn is the impedance between A and B. This is the value of Zn. Okay, same just like Zth. There is no difference. If you see a voltage source, you should short it. If you see a current source, you should open it. Okay, so here we mark it. This is 5 ohm, this is 10 ohm, this is 2J, and this is 5 ohm. This is 5 ohm, this is minus 2J, and this is 10 ohm. Okay, all right. So now A and B. Okay, so now when if you look at these two branches, right? If you look at these two branches, this point is the same. This end point is the same for both the branches, and this point is also the same, right? Because there is no element over here. So this entire connection, this entire wire over here, this horizontal line, this vertical line, and this horizontal line is actually a single connection, which means these 2 points are also the same. In other words, these 2 branches are in parallel to each other. So therefore, if I'm going to combine these two, this will become 5 into 10 minus 2J by 5 plus 10 minus 2J. Okay, which is basically, this is nothing but, this is 50 minus 10J, right? 50 minus 10J by 15 minus 2J. Let's see what do you get. That is 50 minus 10J in divided by 15 minus 2J. Okay, and you will get the answer as 3.362 minus 0.218J. Okay, this is the value of by combining these two. Similarly, these two branches are also parallel to each other, right? Because the one end of the branch is of both the branches is connected to B, and the other end of the branches are also connected to the same connection, right? So therefore these two branches are also parallel to each other. So which means if I want to find the parallel of these two connections, it will be 5 into 10 plus 2J by 5 plus 10 plus 2j, which is basically this is equal to, this is 50 plus 10j by 15 plus 2j, which is equal to, we see, so just simply change the sign, right? Here it is plus 50 plus 10j, and here it is 15 plus 2j, 15 plus 2j, and you get the answer as 3.362 plus 0.218j. Oh, how nice. So these are the parallel connection, which means your impedance is now looking like this. This A is connected to this element and this B is connected to this element, which means this is A and the impedance value of this is this one, right? 3.362 minus 0.218j. Okay, and as for here, B is connected to this impedance, right? That's this one over here. So this is 3.362 plus 0.218j. Okay, this is B. So you can see that now these two elements are in series because the same current flows through both of them, right? So these two are in series. So what will be the answer? You can see if you add these two, the imaginary part will cancel each other, right? So only the real part is remaining, that is 3.362. So just simply find 3.362 into 2. 3.362 into 2 is 6.724. Therefore Zn is equal to 3.362 minus 0.218j plus 3.362 plus 0.218j, which is equal to 6.724 ohms, which is basically a Norton's resistor, right? So therefore this is the voltage, that is we have this, this is the current, that is we have a current source, okay, and then you have a resistor, an impedance. I will draw the resistor because there is no imaginary part, so I will simply draw as a resistor, and this is 6.724 ohms, okay, and the value of the current source here you already found out, it is 0.53 angle minus 164.337 degrees, minus 164.337 degrees amperes. Okay, this is the value you got. This is the Norton's equivalent of the given circuit. Okay.